a power of 10 to estimate a quantity? Think about this question during the lesson. Janelle is comparing the estimated populations of Japan and China. The estimated population of Japan is 126,818,019. Here's the estimated population of China. How can Janelle compare the two populations more easily? You can estimate large quantities and write them in a format that is easier to compare. Janelle knows the populations of China and Japan. Why might she want to estimate the population of a country? The population is constantly changing, so it makes sense to work with an estimated quantity. To begin, estimate each population by rounding to the greatest place value. The population of China rounds to 1 billion, and Japan's population rounds to 100 million. How do you determine whether to round the initial place value up or down? Look at the place value to the right of the initial place value. Round up if the number is 5 or greater. The initial number does not change if the number to the right of the initial place value is less than 5. Janelle can write each number as a single digit times a power of 10. She can count the zeros to determine the power of 10. 1 billion has 9 zeros, so it can be expressed as 1 times 10 to the power of 9. There are 8 zeros in 100 million. 1 times 10 to the power of 8. Janelle's second step is to compare the estimated values. Which symbol correctly completes the statement?
Select your answer.
Ten to the power of 9 is greater than 10 to the power of 8. So, 1 times 10 to the power of 9 is greater than 1 times 10 to the power of 8. That's how Janelle can use estimates with powers of 10 to compare the populations more easily.
Light travels 299,792,458 meters per second. Sound travels at 332 meters per second. Use a power of 10 to compare the speed of light to the speed of sound.
Okay, so we're going to round to the greatest place value. So that greatest place value is the millions. And so there's a 9 next door. So we're going to round up to 3 million. 300 million, I'm sorry. And then for counting the zeros, we have 8 zeros. 6, 7, 8. And then the estimated, so 322 round to the greatest place value. Let's do that while I'm here. So that's 300. 2 is the next door neighbor, so we keep it at 300. There are 2 zeros in the rounded number. So the estimated speed of light is so the estimated speed of light is 3 times 10 to the 8th power. 3 times 10 to the 8th power. And the estimated speed of sound is 3 times 10 to the power of 2. And that goes here as well. So 3 times 10 to the power of 8 is greater than 3 times 10 to the power of 2. So the speed of light is faster than the speed of sound.
Matthias used a laser to measure the average thickness of human hair. A sheet of paper is about 13 ten-thousandths of a meter thick. How do the two thicknesses compare?
So the estimated thickness of hair using single digit and a power of 10. So we're going to round this number here to the nearest place value. So that's going to be that 1 there. So 7 is next door, so it rounds up to that 2. That's why you see 0.0002. And so you count how many zeros, and it's 2 times 10 to negative 4. And it's negative 4 because it's a decimal. So that's why you have that negative exponent. So you compare the estimates, but let's look over here first. Now we're going to compare the thickness of the paper. Round to the nearest digit, it's a 1. That's next door, so going around to the 1, and then you have 3 zeros, and it's negative. And so 2 times 10 to the negative power is less than 10 to the negative power of 3. So human hair is thinner than a sheet of paper.
How does the gross domestic product, GDP, of Canada compare to that of the United States?
All right, so you have the gross domestic product values here. Oh, didn't mean to click that. All right, so step 1, write each GDP as a single digit times the power of 10. So you have Canada at 2, and then you add all the zeros. Then you have USA, and then you add all the zeros. Compare, and so 2 times 10 to the 16th power is greater than 2 times 10 to the 15th power. So the US GDP is about 10 times as great as that of Canada.
There are approximately 1,020,000,000 cars in the world. The number of cars in the United States is approximately 239,800,000.
Okay, so we're going to look at the first digit, the 1, and next door is a 0. So we have 1, 1, 2, 3, 1, 2, 3, 1, 2, 3. So this is equal to 1 times 10 to the 369th power. Then look at the next one, and we have 2. Next door neighbor is a 3, so it stays 2. Then we have 0, 0, 0, 0, 0, 0, 0, 0, 0, which is equal to 2 times 10 to 8. Okay, and then now we have to compare. And so the cars in the world, we have 1 times 10 to the 9th power is going to be greater than 2 times 10 to the 8th power. That's it.